All right, so we're looking at lesson number 4 here, and what we're really doing is making the transition over into the algorithm. We're going to show you more models, but the whole idea is, come on, let's not do this. Let's show you how we can get this done. So, what we want to make sure is realize is equivalent fractions, because part of what equivalent fractions is when we use that phrase, common denominator, which we'll be seeing here shortly, we're getting equivalent fractions. So let's just jump down to 10/12s here. All right. One way to get equivalent fractions is to simplify. We can divide both of these numbers by 2. So 10 divided by 2 is a 5. 12 divided by 2 is a 6. So you get the answer of 5, 6. We could also, all right, to get equivalent fractions, is we can multiply by the exact same number. So, for example, 10 times 2 gives me 20. 12 times 2, and again, it's got to be the same number, gives me 24. These are all equivalent fractions. And check this out. 5 times 4 is 20, and is 6 times 4 24? It certainly is. So again, equivalent fractions means, hey, we're all the same. We're just kind of written out a little differently. So we're going to skip example number 1. Actually, no, we're not. We're going to do this one there. So this kind of goes off of what we did from yesterday. So we're going to have 11/8 cups of strawberries. So we're going to get our visual for 11/8. So I'm breaking it up into 8s, but I need 11 of them. So I'm just going to draw the 11 right from the beginning. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And again, I need all 11 of them there. So we're going to use all of them. And I want to put them in groups of 2 8s. So groups of 2. There we go. It's group of 2. You get one there. Groups of 2. You get one there. Yep. There's another one. There's another one. There's another one. And yeah, I do have one that's left over. So how many groups? 1, 2, 3, 4, 5 groups with one piece that was left over. And I was trying to put them in groups of 2. Now, not groups of 8. No. We're not using that denominator there. We're trying to look at what are we trying to put in groups of 2 8s. All right, so 5.5 is our answer. Now, the reason why I wanted to set you up for that one is because when we look at the very next problem here. Now, what happens here is we've got 11/8 again, but the issue is I'm breaking it up into 8s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. But it says he eats 3/4 for a serving. So the idea here is I'm doing 11/8 divided by 3/4. I can't do groups. Each of these is worth an 1/8. So I need my 3/4 to be out of 8s. So 3/4, I want it out of 8. So what do you do to 4 to get to 8? What do we multiply it by? It does need to be multiplication. You multiply it by 2. So 3 times 2 is 6. So the real problem we're doing here is 11/8 divided by 6/8. Now again, we want all of them. So we want groups of 6. Each box is worth an 1/8. So 1, 2, 3, 4, 5, 6. There's a group. 1, 2, 3, 4, 5. Okay, so I got one group and I had 5 pieces left over, but I was trying to put them in groups of 6s. Yeah, 1, 2, 3, 4, 5, 6. Remember, 6 8s, groups of 6 there. So it says we can use the standard algorithm to prove this problem. To use the standard algorithm, we have to use the reciprocal of the divisor and then multiply the fractions. Okay, so reciprocal. Reciprocal means simply to flip the fraction. All right, flip the fraction. Now, it says the divisor. So which fraction is that? The divisor is the second fraction. All right, so watch what ends up happening here. Let's get a little space here. So we're going to show you both. All right, use the model and the standard algorithm. So 3/4 divided by 2/3. Well, in order to do this, at first I'm like, well, let's divide it up into 4s, but no, I can't get groups of 3. I got to get common denominators here. So 12, yeah, I can do it out of 12 there. So 4 times 3 is 12, so 3 times 3 is 9, and then 3 times 4 is 12, so 2 times 4 is 8. So this is the real problem I'm doing there. So now if I'm doing the visual here, I need 12s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. I want 9 of them. All right. Oops. Oh, let's get that rid of that one. So this guy should. Oh my goodness. All right, let's try that again. It'll be a little more careful. There we go. So there's my 9 of them there. But wait, I need each one's worth of 12. All right, I need groups of 8, 12. So it takes 8 to make a group. So I get 1. How many pieces are left over? Well, there's 1 that's there, and I was trying to put them in groups of 8. So 1 and 1/8 is my answer. So again, it works, but watch what happens here. 3/4 divided by 2/3. 3/4 divided by 2/3. What we end up doing here is multiplying by the reciprocal. So if I take 3/4 and I times it by the reciprocal, and again, reciprocal means to flip the fraction. Watch what happens here. Any cross division? No. So 3 times 3, 9. 4 times 2, 8. Guess what 9/8 simplifies to? Yeah, it does. Again, 8 and 9. So really what you're watching here is, if you noticed, 9 divided by 8, there it is, 9 divided by 8. So yes, we can get common denominators, but let's think about this, people. What's one of the reasons you dislike adding and subtracting fractions so much? What is it? What's the reason there? The common denominators. Yeah, you don't like the common denominators because that's a lot of work. Cross division and multiplication. Multiplication of fractions is a lot faster, all right? So let's make sure we stay away from those particular common denominators and get ourselves using that algorithm method. So let's, you know what? All right, just to prove the point, let's do one more, all right? So 6/2 divided by 3/4. Now again, we need to be talking the same language, so I can use fourths here, all right? So that's 3/4, and then, I got to multiply by 2, so that's a 12. So I could go ahead, write out 12. Oh gosh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, you can see the hassle already. So I need all of them. I need groups of 3 since each is worth a fourth. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Oh, exactly. It's exactly 4. All right. But watch what happens right at the beginning. 6/2 divided by 3/4. Leave the first fraction alone, change it to a multiplication problem, and take the reciprocal. Do you see any cross division? Absolutely. 3 into 3 once, 3 into 6 2 times, 2 into 2 once, 2 into 4 2 times. Multiply across, and you get the answer of 4. No more boxes. All right, no more boxes. So let's shut it down right there. That's the end of lesson 4. All right, let's skip those guys. Let's get ourselves right to lesson 7. All right, and let's formalize this. So steps for dividing fractions. The first thing that we have to do is we have to rewrite the problem. All right, and when we rewrite, we're talking about you need to multiply by the reciprocal. All right, remember what reciprocal means is we are going to flip. All right, we're going to flip that fraction. Then we're going to go ahead and we're going to look for a cross division. All right, then we'll multiply across. And as always, we got to check to see if we can do any sort of simplifying. Here's the thing, people. We never divide fractions. It becomes a multiplication problem. So 3/4 divided by 2/5. 3/4, leave the first fraction alone. We change it to a multiplication, and we flip the second fraction. It is a reciprocal. So when we do that, check for cross division. Do you see any? Do you see any at all? No, I don't see any either. So it's okay. Don't get upset about it there. No, it's okay. All right. Just multiply across 15/8. Nothing fits into 15 and an 8, so you could leave it like that. I'd also take the simplified answer. You could end up saying it went in 1 7/8. So I would take either one. So I'll put an or here. All right. I will take either of those particular answers. Let's go down to example number 1 here. All right. And this is another reason why we want to get away from the visual here is because, oh my goodness, 20 boxes? Are you kidding me? Yeah. So leave the first fraction alone, change it to a multiplication, and flip that second fraction. All right. So there's my rewriting. Do you see any cross division? You should say yes. All right. 10 goes into 10 once, into 22 times. You can multiply across now. And then if you want to simplify it down to 1 7/8, you could do that. I would take either of your answers. All right. Here, oh my goodness, common denominator, 33 boxes? Yeah, no. So change it to multiplication. Flip that second fraction. And again, multiply by the reciprocal. That's the phrase. We change it to multiplication and then we flip it. So look for cross division. There it is. All right. 6 goes into both of those numbers. And then look for more cross division. Yeah, 11 fits into both of these numbers as well. And when you multiply across, your answer is 3/2. If you'd like to, you could break it down into 1 1/2 if you'd like to do that. Here's what I want you to do. Go ahead and look. There's question 3 and there's question 4 waiting for you. Go ahead and do questions 3 and questions 4. This is one of the things I want you to end up, I won't be checking for in class. All right, people, that's it for right now. We'll be back. No, it's okay. It's all right. We'll see you later.